Okay, continuing on with this example here, I've gone ahead and worked a little bit out with F2 and F3. Before we look at those though, I want to go back to F1 because I realized I had made a slight error here. Because the Y component is actually heading down, instead of saying plus 75 sine of 70 degrees, what we want to do is have a minus because it's actually heading in the negative direction there. So let's see if I can erase this. I don't know whether it's going to work. Nope. I don't know why I'm having trouble with that tonight, but here we go. Let's just cross that out and just go minus. Make sure that that's changed to a minus value there. All right, so F2 heading to the right, so this is a positive 120 times the cosine of 50 degrees, and that's in the positive x direction, so that's times by I hat to head suggest that we go that way, and we do want a plus in this case because we are heading upwards. 120 times the sine of 50 degrees here. Okay, so from there I can now state also my force vector 3, and I'm going to have my x value heading to the right, so it is positive, and it's going to be in the x direction, but we want a minus because that's heading downwards, so we have a negative j vector with that one. And I forgot my j hat up here. Goodness. Okay, and we have our j hat here. Now what we want to do is add these three vectors together to get the resultant. Now, at least that part's cooperating with me tonight. So what I really want to do is take these three vectors and I want to add them together. So I'm just going to write out the three vectors. Cos 70 degrees I minus 75 sine 70 degrees, and then we've got our j hat. Vector, force vector 2 is 120, and then we have the cosine of 50 degrees times the I hat plus 120 times the sine of 50 degrees j hat. And then we have vector 3, force vector 3. And notice I'm lining up all of the I hat vectors together, and the j hat vectors are lining up underneath each other as well, because we're going to do columnar addition here with these. Okay, so we're going to actually add all of these things together. So we've got F1, vector F1, plus F2 plus F3. That is going to be our sum. So we've got F1 plus F2 plus vector F3. That's going to equal, and then what we do is we're going to add all of these things together, and that will give us our overall x component. And then we're going to add all of the j hat stuff together. So I'm going to actually punch this into my calculator all in one kind of foul swoop here. 75 times the cos of 70 plus 120 times the cos of 50 plus 90 times the cos of 25. And that will give me my sum, or the x component of that vector. Okay, when I added those together, I got 184.3, and then that's an I hat there. And then I'm going to do the same thing with my y components. I'm going to take that negative 75, and I'm going to multiply that by the sine of 70. And to that, I'm going to add 120 times the sine of 50. And then I'm going to subtract 90 times the sine of 25. And I get 124.4. And I'm just going to double check that and make sure I haven't made any mistakes with it. Okay, and when I double checked it, yep, I got a different answer. So, and I checked it, actually triple checked it. I'm not going to lie. I got a minus 16.6 roughly, and that's in the j direction. So my resultant, if I were to actually sketch that resultant then, what it looks like is I'm going positive 184 in the x direction. So 184.3 is my horizontal component, and my vertical component is just down tiny little bit here, so that makes this my resultant value. So now what I'm going to do is apply that Pythagorean theorem. So this is 184.3 and 16.6. It is negative, but I've already drawn the negative part downwards, so I'm good with that. Apply Pythagorean theorem there. If you do, you should end up with, if I've done this correctly, I got 185.1 being here, 185.1 newtons, and that was by the Pythagorean theorem. Now to get my angle, what I'm going to do is solve for my theta here. I'm going to use my tan, so tan of theta, I'm just trying to squish this in here, tan of theta will equal 16.6 divided by, just moving that over, 184.3, and inverse function tan theta, I got, what did I get for that? I got about 5 degrees there. Okay, so I could say that we are going south and then 85 degrees to the east. Okay, so I would put a therefore statement with that, but as you can see, I've kind of run out of room at the bottom here. But overall, we're looking at this is the magnitude, and then we could say south 85 degrees towards the east, or you could say, not as commonly, but sometimes people will write east 5 degrees south. Okay, more common to put the south or north first. So there you are. Try the last example, and I will post what my solutions were. Actually, I did put what my answers are for that one. But try that one, and if you get stuck with that, please let me know in class and I'll help you with it.